Today's lesson we'll be discussing section 10.4, which is about common logs. What we'll be doing is identifying what a common log is and to use the change of base formula using common logs to find the value of certain logs. And what a common log is a logarithm base 10. This is what your calculator is programmed for. The calculator, the log button, is only programmed log base 10. So how do you find different logs of different bases? This is where we're going to find out. This is where we will start to be able to use our calculator in computation aids. Okay. A couple of different values. Common log, this would be called common log with no base shown, it's base 10 assumed. Common log of 1,000 really means log base 10 of 1,000. What is that? That's log base 10 of 10 to the third. What does that equal? It's equal to 3. Okay, you can verify that with your calculator. Okay, common log of 0.01. Okay, you can verify that with your calculator, but what is 0.01? 0.01 is 10 to the negative second power. Okay, so y equals -2. Now, common log of 50 cannot be rewritten as a power of 10. So we would just need to use our calculator. So we get out our calculator, we put in common log or log of 50, and we have our value. Okay, logarithms are used to aid in arithmetic computations. Okay, one of their more common uses, two of their more common uses, are used in the Richter scale in terms of measuring for earthquakes, and using them in the decibel scale for a measure of loudness. We want to find the logarithm of each number rounded to 4 decimal places. In doing this, you just simply use log of that number, 5.07, and round it. Okay? These are strictly calculator problems. Okay? Common log of 286.1, common log of 0.496, and common log of 0.00008. Okay? This is a new terminology, an anti-logarithm. Okay, what is an anti-logarithm? An anti-logarithm is doing the reverse. It's finding, instead of log of what number, okay, it's finding 10 to what power equals this number. So say the 2.162. Okay, so it's reversing the process. Okay, so if I want to find the anti-logarithm of 2.162, we only find anti-logarithms of common logs. It's 10 to the 2.162 power, which is 145.2112. And again, strictly calculator problem. Okay, same with the rest. Okay, you'll see all the rest now. Okay, all in each case, if I want to find the anti-logarithm of that number, I put in 10 to that power and get that value out. Well, this is, again, what common logs do for us, and what the calculator will allow us to do is we will be able to find log values of different bases. It's called using the change of base formula. Okay, the change of base formula is strictly used for arithmetic computations using calculators and computers, okay, with other bases besides base 10. Okay, so if we have a logarithm, this is log base a of n. Okay, what happens is, in order to do this, we take the common log of the n divided by the common log of the a. Okay, a couple conditions is, again, the base can't be 1, it has to be positive, and the n has to be positive. Those conditions have been consistent throughout all our logarithms up. So we can find the log base 5 of 75. Now 75 cannot be written. It's not 5 to any power. I don't know what power it is. Okay, so to approximate this value is a calculator problem. Okay, you take the common log of 75 divided by the common log of 5. I suggest when you're inputting this in your calculator, use parentheses. It's my suggestion. Okay, and you have your value. Okay, same with the next one, log base 12 of 2. You cannot rewrite 2 as a power of 12. So we write common log of 2 over common log of 12, and we have our value. Okay, same for our last one. Common log of, or log base 1.3 of 67. We take the common log of 67 divided by the common log of 1/3. And again, I would specify for you in doing these with your calculators, put those in parentheses. Now, what we really want to get into now is being able to solve. How can we solve exponential equations that don't have same bases now using logarithms, and we're going to be using common logs. Notice we have 4 and we have 80. 4 can be rewritten as a power 2, but 80 cannot be rewritten as power 2 or power 4. So how are we going to solve this? Okay, we're not going to rewrite them as the same base. We're going to use common logs. Okay, remember, you can do anything to an equation as long as you do it to both sides, including taking the common log of both sides. Okay, we can take the common log of both sides. What that allows us to do now is bring the x that was the exponent out front as a coefficient. Now it's x times common log of 4. Now this is the tricky part. Common log of 4 is a number. That's all it is. It's a number. You can plug in your calculator and get this decimal equivalent for it. So what can we do with it? We can divide it away. Okay? So we're going to divide both sides by common log of 4. Now your calculator can handle the rest. It's like a change of base formula. X equals the common log of 80 divided by common log of 4. Solve that, and we have our value of x, and rounded to 3 to 4 decimal places. See another example. One more example. Okay. Sometimes these get where you have to keep track of some decimals for a decent amount of time, and you just have to be patient with them. Those of you that try to do too much in one step may have a little issues with these. Okay, but we cannot rewrite 2 and 5 as the same base. So what we're going to do, we're going to take the common log of both sides. Now these exponents come out front. Exponents come out front. Okay. So what we have is x times common log of 2 and x minus 2 times common log of 5. There's a couple things we can do here. You can find the approximate value of common log of 5 and distribute it, okay, and find the approximate value of common log of 2 and use that decimal and just keep track of the decimals. That is absolutely a valid method. Or you can do this, okay, where you divide, you take the x minus 2 and divide it to the left, and you take the common log of 2 and divide it to the right. Okay, kind of creating a proportion, but not quite. Okay, what we're going to do is get the value of common log of 5 over common log of 2. Now basically make a proportion out of that. Okay, so when I cross multiply now, I do distribute the 0.2 or 2.32196 to the x minus 2. Okay, and x equals that value now. And now I solve. Again, I told you, sometimes you have to keep track of some decimals. Notice that I'm going more than 4 decimal places just to keep it some accuracy. Okay, in the end, okay, I will go to 3 to 4 decimal places. There's our answer. These are the 2 examples that you need to have done for class tomorrow. Okay, so please have these worked out. Okay, we will go through them in class. These will be checked as your proof of watching the video and doing the work.